Welcome, ladies and gentlemen, to the Darwin Centre. To those of you joining us on the web, it's a pleasure to have you joining us as well. Today, I'm very pleased to have Martin Hall from our entomology department. He is a world expert on maggots and flies, and today we're looking specifically at how these flies and maggots can help us look at murders and crimes and help us in the courts to catch the criminals. So let's give a round of applause to Martin Hall.
Okay, thank you very much indeed, Matt, and thank you to all of you for coming along this afternoon on a nice sunny day to come indoors and hear about forensic entomology. Well, what is forensic entomology? Basically, it's the use of insects that are found at crime scenes in some way to investigate that crime. And the insects that are most often used are these ones here. This gives an indication of them. This is a lovely old picture from 1491, and it shows a leg of beef there, and those ovoid things crawling around on it are maggots, and as you can see above, they turn into flies. Well, I've got some maggots here with me today, and they were writhing around on the screen a little earlier, so let's get them writhing around again. And we're just going to have a little experiment. These things here are finished feeding, and they're ready to look for somewhere to turn into pupae. There is actually one pupa in there already. It's the black thing in the middle, but there's a bit too many in here, so we'll just get a few of them out. And these things are looking for somewhere dark to turn into pupae. So what we'll do is we'll cover up half of the tank with this dark thing here, and we'll have a look at them a bit later on and see if the experiment works. I don't say it will, but hopefully you'll see most of them will move into the dark to get away from the lights. So whereabouts do you find these maggots in nature? Well, if you go wandering around anywhere in the country and along roadsides, you'll find things like this. This hedgehog didn't cross the road quite quickly enough and got squashed. This is about 7 days after death, and you can see it's full of maggots there. But it's not just little animals that are affected, but big ones as well. And here's an elephant that I found in the Zambezi Valley of Rakomachi, and you can see that my colleague Fred there is pointing out the massive maggots at the base of the head there, and in fact they're all along the body line there. And within about 10 days, all that was left of the elephant was this here. And the vast majority of that decomposition is due to insects, and they're basically turning one elephant into millions and millions of maggots and then eventually into flies. So very important in nutrient recycling. Well, that's where forensic entomology comes in, because it's not just dead animals that are attractive to flies, but humans too. And we can see, going back to our 1491 book again, you can see here a picture of a person who was ill and falling asleep. Well, if he fell asleep, he'd be able to brush those flies off. But if he's actually dying and eventually dies, then he won't be able to brush the flies off, and they'll go on and examine his body, and perhaps they'll lay their eggs, and they'll start the process of decomposition. And that's what we here at the museum, as forensic entomologists, try to interpret. And in fact, it's maggots like those that were first found used successfully in the UK, in this case here. These are maggots in our museum. Actually, the museum's a real treasure trove, and I found this bottle at the back of a cupboard. It comes from 1935, and the maggots in there were removed from the bodies of the victim of a chap called Buck Ruxton. He's a doctor who was based in Lancaster, and he murdered his wife and his wife's maid. And then he drove up to Dumfriesshire in Scotland, and he dumped the dismembered parts of their bodies in a ravine there. And when the body parts were discovered, these larvae were removed from them, and they were taken along to a laboratory, and they were identified. And this is the adult fly. It's a bluebottle fly. And they were aged, and that aging fitted in with when the body parts were dumped, and it actually fitted in very well with the movements of Buck Ruxton. And it was part of the evidence that was put towards the case against him, and he was found guilty of these murders and hanged. So 1935 was a crucial date in forensic entomology in the UK. And forensic entomology has come to the attention of the public generally these days. If you watch Crime Scene Investigator on the TV and any number of other shows, you'll see blowflies. And this new novel here by Patricia Cornwell, Blowfly, says devilishly clever, the observer. I didn't actually think it's that brilliant, but most worrying was the picture on the front here. This is a blowfly, and I'm a taxonomist at the museum, and one of our big things is identifying insects. And if you look carefully at this, you'll see it's not a blowfly antennae at all. Blowfly antennae are very, very tiny, And these things here are very long and thin. And they're clearly an artist who got this picture thought, well, this doesn't look like proper antennae. He'd have been used to looking at butterflies or something. And so he stuck these on. Anyhow, how do these flies find a dead body? Well, to discover that, we're going to have to travel to Mexico, where I've done some work on about one of the world's biggest fly zappers. And I've got a smaller version of one here. This is Tim Henman's new weapon for next year. It's actually a little electrocuting device, and it was playing up earlier, but let's hope it works. So here you have a big fly coming in, and he gets well and truly zapped on this electrocuting net. Well, that's what happens with this big net here. Only I wasn't using 2 AA batteries, I was using 3 car batteries there, and there's something like 30,000 volts going through the fine grid of wires that you can hardly see on those nets. And basically the flies can't see it either. And what happens is they fly up, and they hit the net and get zapped and drop down into these water trays underneath. And in this particular case, in 2 of the water trays, I've circled their small bottles, and I've got a substance in there, it's called swarm lure. It really smells like a decaying wound on an animal. And that's a sort of smell that attracts blowflies. And you can see that they come in very well. Here's one of the bottles, and you can see all the flies in the tray underneath there. And if you go and count all of those trays, there are 12 trays underneath the nets there, and you can draw a graph here. You'll be used to drawing graphs in your school, so here's a nice one. And you can see there are 2 peaks there which indicate where those flies were. So let's put all the flies in, and you can see that those flies were able to find those bottles, even though really the bottle wasn't like a dead body. There was nothing for them to see, but they were just to home in by smelling the smell of that decaying flesh, synthetic decaying flesh. And blowflies are really very good at being able to sniff out where a body is. So if you murder someone, don't hide them under the floorboards, because most houses in the UK have got air bricks, and the smell of the decaying body will go out through the air bricks, and the flies will fly upwind and find the air brick, and they'll crawl inside and they'll find the body as well. So what do they do once they get to the body? Well, here's a picture of a dead pig, or part of a dead pig, and these are its guts here, and you can see the flies have arrived, and these ones here are actually feeding at the moment. They're not doing anything else, they're just feeding. But they will actually go on and do egg laying as well. Perhaps we could just have the first video of some flies feeding. It's just a very short little video and not particularly good resolution, but you can see it's a very busy place, a dead animal. This is a dead piglet here, and there are lots of flies. Here's a big one just arriving, a big blue bottle, trying to push in there and find some place at the dining table. And then we'll just move on to have a look at a clip of a sticky paper which was over a piglet, and it was catching flies that were arriving at the piglet. And if you look carefully, you'll see lots of flies buzzing around on this sticky paper, and you'll see some of them will have laid eggs. And the eggs are the yellow bits. We'll see them in just a couple of minutes as we scan across, with the slightly white at the top there. That's a batch of eggs. And there's another batch of eggs here and another batch of eggs there. So these flies are doing 2 things. They're arriving to feed on the body, like these ones here, and they're also arriving to lay their eggs. And of course the eggs turn into the next stage, which is the maggots, and here's some of them. So how do we go about collecting these maggots at a body? Well, when I'm called into a scene, and the first thing to do is don some nice protective clothing. It's not a very nice environment, as you can imagine, and I'm always rather embarrassed. My son's particularly embarrassed when he sees me leaving the house with this thing here. This is full of all the things I need to collect maggots at a crime scene. And obviously I've got lots of bottles to put things in, torches if it gets a bit dark, wipes to sterilise myself after I've got all messy, the sort of overalls that you see on the screen there, and also bottles of preservative like this. This is alcohol that we put them in. But perhaps the most important tool is this bent spoon here, because this is actually the easiest way to collect maggots from a body. You'll see someone later collecting them with forceps. In fact, let's have a quick look at that now. We'll have a look at collecting maggots, not from a human, but from a piglet. You can see there's lots of maggots here writhing around, and there are all different sizes there. There are some larger ones from the flies that came in first, and there are also some very small ones. And my assistant here is using forceps to collect them, but it's much easier actually just to scoop up using a spoon. Sometimes at the scene we don't just collect from the body, but from around the body. And here is a team of people who are digging around where a body's been lying. Because what happens is when they finish feeding, the maggots will move away, just like the ones in the tank there, and it looks like the experiment's actually working, which is a relief. You can see if I take the cover off, most of them are ended up underneath the black cover. I'll put that back again, you can have a look later. So if we go back here, you'll see here highlighted some larvae which have wandered away from the body, and they've actually been around the bole of this tree trunk here. Sometimes we can't collect at a scene and have to go to a post-mortem as here and collect specimens, and sometimes still we can't even do that, and we have to rely on the police collecting specimens and sending them in. And these are from the Hertfordshire Constabulary, as you can see. Well, what do we do with the specimens once we got them? Well, as I said, we're here in a taxonomic institute. The important thing is identification and classification, so we need to identify them. And to identify, to put the name on these bugs, the ones on the left there, Califera vicina, that's a bluebottle fly, is just as important as for the police to get the car number plate. Because what you can do then is feed all that information into your database, and then you get out all of the data on the car or on the insect, and that will give you an idea about where you're likely to find the insect, what season of the year you're likely to find it, and so forth. And the next thing is to age the insects. And to age them, you need to know something about how they develop. And here's a picture of a life cycle of blowflies. So you have the adult flies in the lower left. They lay eggs, and these eggs hatch out, and they grow remarkably rapidly within about a week, and they get huge in their size from what they started with. And basically, you can age them by measuring their size, because that's related to age. But what's also important is to measure the temperature. And so at any of these crime scenes, I'll take along a little data logger here. This is a temperature recorder. And I can leave that at the crime scene and work out what the temperatures are, and then relate them at the crime scene to temperatures out to a nearest meteorological station. And I can then use that to predict what the temperatures were like before I found the body, and hence what the temperatures were that the maggots were developing under. And we do a lot of work in the museum here. Here's Zoe Adams, and she's working on our collections of blowflies. And I've got a cage of flies here. These are just common blue bottle blowflies, what these maggots here will emerge into. And we do a lot of work at the museum trying to work out how rapidly these flies develop under different conditions. And we also do work using dead animals. And we've done some work recently at the museum using small piglets. These are piglets that have died at birth. Pigs aren't very careful mothers at times, and they tend to roll over and squash the piglets. But we can use those and expose them inside and outside. And you can see there could be remarkable differences. These are piglets, the one on the left exposed inside and the one on the right outside during December, January. And you can see after 27 days, that's what was left of the piglets. The one on the left has completely disappeared, and it turned into about 4,000 flies, whereas the one on the right, because it was cool conditions in the winter, is almost whole. Well, the bowl on the left here, you can see it's full of those brown puparia, equivalent to the chrysalis of a butterfly. And sometimes that's all that you'll be left with at a crime scene. The blowflies on the left have emerged from the puparia on the right. But even if you just find these puparia, it can provide useful information. This picture here is from a crime scene in Nottinghamshire where a body was found in a cupboard. And if you look at the bottom of the cupboard, and all that sort of black stuff on there is body fluids from the deceased who's been removed from the cupboard, you can see there are some puparia here. And we were able to age them and then give the police a minimum time that that person must have been dead. And that allowed them, because this was a pretty busy place, allowed them to exclude a large number of potential suspects, so they could focus on the right people. And I'm just going to show you now an example of how you use forensic entomology to murder. This took place in Essex, and the body was placed in a bunker underground, and you approached it down these steps here, and you turn into the underground bunker, and there at the end of the bunker was the dead body. And this was covered in maggots, and they were removed. And then if we look at this timeline here, each of these boxes is a day, and we were able to age the maggots, and there were a lot that had been laying their eggs over the last 6 days or so before we found the body. But the oldest ones, and those that must have laid their eggs on the body first, were aged back to the 13th of July. Well, at the time, the police had got no idea how long that body had been dead, because the pathologist couldn't give them any accurate information at all, other than it was dead probably more than 3 days. But we were able to say, well, it must have been dead sometime between the 12th and the 13th of July. And later in inquiries, it came out that there was a fire that was spotted in that area around the 12th of July, and this person had actually committed suicide and had died at that time. But as you can see, we weren't able to say who had killed the person, or whether it was a suicide or not, but we were able to point the police in the right area for their investigations and save them a lot of time and money. Well, it's not all maggots and murders. Other ways that we can use insects at crime are in identifying the origin of cannabis. Well, I'm pleased to see the head of our department at the back here. He doesn't know that I've been looking at cannabis plants. This is in Morocco on one of my recent trips. I wasn't using it illegally, but this particular case involved an importation of cannabis into New Zealand, and it was back in 1982. And importing cannabis carries a much heavier penalty than just growing it in your back garden. And these New Zealanders who were arrested, they said that they had just grown it in their garden. Well, it was about 180 kilos, which is a huge amount. And when they looked through it, they found quite a lot of different insects in there. And those insects were identified at the museum here, not by me, but by my colleagues. And they were able to overlap all the distributions of the different insects there. And I've just shown the distributions of 2 of those insects, but already you can see that there's a square in the middle there, which is where those insects have come from. And when they overlapped all of the distributions of all of the species, they actually pointed out that Tenasserim region of Burma as being the origin of the cannabis. And when they were faced with that information, the defendants changed their plea from not guilty to guilty. And as the New Zealand newspaper said here, insects pinpoint drug source. And a slightly more bizarre example of forensic entomology is a recent case in the museum. It featured this rather splendid leopard skull here. This was found on Bodmin Moor, and the question was, is this the beast of Bodmin Moor that's been terrorising walkers and sheep on the moors there? Well, the question was, had it lived on Bodmin Moor? It was sent to our zoology department, and one of the curators there examined the skull and compared it with others in our collection, and were able to identify it as an Indian leopard, and it was a young male. But when she looked inside the skull case, she found actually this strange object here, which is the egg case of a cockroach. And so it was passed across to the entomology department, where Judith, our cockroach expert, had looked down the microscope and identified it as a tropical cockroach. Now, these cockroaches are sometimes found in hot houses in the UK and stored products places, but they're certainly not common on Bodmin Moor. So clearly this was just a hoax and someone's idea of a bit of fun. But it needed this forensic entomology to really get to the bottom of it. Well, police operations these days are really big things. This particular car park here of police vehicles is one of 3 car parks in Sussex for this particular case, and many millions of pounds were spent on the forensic investigations. Now, it's unlikely that the entomology can actually identify a particular suspect, but it can be one jigsaw, one piece of the jigsaw that points towards the person guilty. Ideally, this is the outcome of forensic entomology. Hope you can see there, murdered 3 p.m. on Friday. Well, we can't be quite that precise at the moment, but certainly we could say that it was Friday rather than Thursday or Saturday. And with continuing developments at the museum and in the United States and particularly in Australia, we hope that we'll be able to push this whole concept of forensic entomology forwards. So thank you very much for your attention there, and I'm very happy to take any questions from anyone who has them. Thanks very much. I'll take this black cover off again, and if you have a look with the camera, you'll see that, whoops, actually these are beginning to escape. I'll put them back in there. So the experiment worked, which is good. They've all run away from the light, and they're all gathered there on the left-hand side of the box.
Are there any questions? Hold on, let me pass you the microphone so the web audience can hear your question. Sorry. Yeah.
How long would they take to turn into pupa if you left the black cover there?
They'll probably take about another day, 24 hours, and the majority of them will turn into puparia, yeah. And the puparia is actually, it's really amazing, it's the hardened and darkened skin of the maggot, and then all of the maggot tissues are sort of dissolved and then reassembled as a pupa, which turns into the adult fly.
Why is it some of them are pink and some of them are white?
Oh yes, okay, this is just for the camera really.
Oh, right.
These are fishing maggots, and some fishermen believe that the fish would be more attracted to a red maggot than to an orange one or a white one. But to be quite honest, when you throw a maggot into most of the muddy waters that fishermen use in Britain, I don't think that the fish really mind what colour they are.
Other questions in the audience? Oh, sorry,
Sorry, they're the same species, are they? The pink and the...
Yes, they're all the same species. They're a rural blowfly, a relative of this one here, which is the urban blowfly. They're blue bottles.
Are there other questions in the audience before we close up the cameras?
One thing I should say is that these have been kept in a fridge now for the last week or so. If I hadn't put them in the fridge, they'd all be puparia by now. But that just shows you one of the problems with using forensic entomology. It's really critical that you can work out what the temperatures are, because so for instance if a person's been put in a freezer after they've been killed and then taken out again after 3 months, what we say is when the flies found the body, not necessarily when that body died.
So if you wanted to really throw off the forensic entomologists, you'd kill the person, throw them in the freezer, and then take them out 3 months later, and then leave them out somewhere, and then you wouldn't know when the murder actually occurred.
But we'd be able to say, well, this chap took it out of the freezer 10 days ago.
Right. So that for those of you planning murders, this is important stuff. Right. Well, anyhow, are there any other questions before we close up? Otherwise, we can just do Q&A one-on-one afterwards. Well, thank you very much, Martin. It's been a real pleasure having you.
Thank you very much, Matt.